Okay. So, well, as you have seen, this talk was meant to be presented by Asad Khan. Unfortunately, he wasn't able to come here to Spain, so he asked me to deliver the talk. So that's why, while yesterday you were having the great tapas night, I was at the hotel working on the presentation. It's but the way the topic of the talk is going to be the same. It's going to be about HDInsight, which is Microsoft's big data product. Well, actually, it's Microsoft a Hadoop cluster distribution, because there are more to big data in Microsoft's platform than this. We will talk about that in the later part of the session. Just let me make sure, yeah, I started on time. So this is me, Pablo Doval. I'm the lead architect and lead of the data team at Clean Concepts, which is Microsoft know-how company from based in Spain, but we have offices all around the world and doing projects all around the world. This is my contact details if you want to discuss anything about these projects we're going to be talking about and products. Please feel free to send me any email, to reach me on Twitter. I really love to discuss about these things. For today, I'm going to be very quick because I have a lot of ground I want to cover. I want to start discussing a little bit about big data and Hadoop clusters. I want to describe and to show you the HDInsight Hadoop clusters by Microsoft. I want to talk to you a little bit about a couple of projects we have been doing and how you can well, engage in this kind of projects as well. And finally, I want to discuss a little bit about what's the future to come. Well, it's not so future any longer. We have a lot of products and good things to discuss here that we can start testing right now. So I will talk about them as well. So first of all, let's start talking about big data. Now, I'm a little bit concerned, because when I showed this slide about the 3 Bs, I was expecting you to be a little bit like this. No, not again. Okay, I'm not going to talk about big data again. I'm not going to talk about the infamous 3 Bs and so on. I just want to get to know just 2 things from you. First of all, who of you have ever engaged in any big data project? By the way, I hate the term big data. Great to know. Any other of you? Okay, good to know. And out of you, how many of you have used, or even if it's not in a project, even if it's just playing with virtual machine or with a cluster on Azure or whatever, how many of you have actually used Hadoop clusters? Please? Okay, then you're going to find this as really enjoyable. Okay, I'm just going to tell one thing about big data, and it's the fact that it's not about the size. That's why I hate the concept or the word big data. I don't really like it, because we tend to think about big projects. Well, actually, I have a very good example on why it's not all about the data. For example, we are working on a 40 terabyte project, which deals with well, cookie handling to identify conversions on digital media campaigns, basically the ads you see on the web, and how all these cookies change together to perform what's called the exposure path, the conversion chain. Okay, that's running actually on a SQL Server box, normal SQL Server. It's a fast track server, but it's normal SQL Server box, so it's purely relational. We are talking about purely relational here, and it's, well, quite a big amount of data. And if we go to the words of PDW APIs, of appliances, of MPPs, massive parallel databases, we are also talking about relational. There's no need to change the way we think about the projects, the way we think about data, to embrace other things like NoSQL, like other things we are going to be discussing later, just because of the sheer amount of data. We have brilliant solutions for that are working perfectly fine. On the other hand, I have a very smallish project. It's about 150 gigabytes of the total amount of data. That's really small. And that's built, in fact, that was the first project we did with HDInsight when it wasn't even called HDInsight, it was Hadoop on Azure, here in Spain, for, well, a wind power company, for Acciona Energía. And it's just 150 gigabytes now, and it's the worldwide production of the engineering data of the windmills. But we went for in this case, a Hadoop and HDInsight solution, and it was just because, not because of the size, it was because of the nature of the data, the variability, the fact that every different turbine has different fields, has different data that we want to track, and so on. So it's not related with data directly. Big data, it's a word I really, really don't like. I have to say that. So we're going to focus anyway today on one of the main projects on let's say, this big data set of tools, which is basically Hadoop clusters. Hadoop clusters, first of all, it's nothing new. The Hadoop project, the Hadoop clusters started based on 2 white papers that Google published in 2005. So it's almost, well, it's 10 years ago. So it's nothing new. Okay. There were 2 papers, one for HDFS. Well, it was called GFS. It was the Google file system. It was a distributed file system. The idea was that, hey, we have so much information, so much data here that it's simply not cost efficient to have a massive set of SANs, of ultra expensive storage. And also, we are going to have to deal, even if we are talking about great storage and great hardware, we're going to have a lot of problems with other issues, like what happens when my hardware fails, and so on. It's not just because of a cost problem. So Google published this white paper and developed this platform that basically based on having a lot of machines, commodity hardware, machines that you can just go and buy from HP or whatever it is, and use the local storage of those machines and create a cluster, a distributed cluster on those machines, on that set of machines, and then to store the data in the cluster, provide a file system that can understand where the data is and go to fetch it and provide it to the user or to another process. That another process basically was MapReduce. MapReduce is a technique of writing code, basically, but it was, in this case, also a runtime, a framework, a Java framework, and a runtime to implement massively distributed software. I'm not going to get into detail. A little bit later, I'm going to discuss a little bit more, but the idea was that I was able to write a piece of code that's going to use this massive set of computers that are going to use the shared storage, and it's going to execute the parts of the code that needs to be executed in the specific machines that host that pieces of code. And in case one of the data nodes fails, it will just automatically find another suitable data node and start executing that part of the code in that node without me as a developer having to care about these retries, about this failure detection, and so on. So the idea was good. This guy, Doug Cutting, implemented the basic idea of Hadoop clusters. And as I told you, it's nothing new. Okay. Now, how they look like? For example, here we have an example of shiny little boxes, small boxes, which are each of those individual computers. This is a very massive, I think this was Yahoo's one, very massive Hadoop cluster. Obviously, we have other kind of Hadoop clusters. I really love the 64 Raspberry Pis on a Lego chassis. I really, really like that cluster. That's my favorite for sure. And then we have this other one. Any one of you knows what's this? This is a very famous picture from Gizmodo. Do you know what's this? Any one of you? This is Azure. This is one of the Azure data centers. The machines on Azure are just these ship containers full of machines. So if anything fails inside of them, we just swap and put another container on it. So the thing is that on Azure and other cloud platforms as well, we can host our HDInsight clusters. And the reason why I think this is important, and you will see that in a minute, the reason why I think this is important is because the fact that I can just spin up a cluster for a very small amount of money means that in order to start working with Hadoop clusters, well, up to now I had one option, which was, well, two options mainly, which was start working for a company that already had a very big or nice on-prem cluster, Hadoop cluster, or B, just get one virtual machine, this kind of sandboxes that you have all in just one single machine, Cloudera, Hortonworks, these distros, they provide you this kind of images, and you start working on them, but you lose a big part of the story, which is playing with an actual multi-node cluster. No? So this allows you to just go and spin up a cluster, start playing with it, shut it down, and well, maybe you spend $10. Well, that was a good amount of money spent for a good learning lesson. So I think this is really, really a good thing. So let's start talking a little bit about the Hadoop ecosystem, because Hadoop, the important thing here is that Hadoop is an ecosystem. It's not just a product. It's a set of products that work together. And let me start with one thing. This thing that I'm going to show you is it's actually not current. When I told you about the future of Hadoop and the future of HDInsight, I will tell you the changes to this. So in the next 20 minutes, I'm going to lie to you. I'm going to tell you how things were up to 6 months ago, 8 months ago. Okay, so this was the old Hadoop. Yes, there is such a thing as old Hadoop, which is Hadoop 1.x. Okay, so initially what we have is these two core items, which is the distributed file system, the distributed computing platform. So we have the HDFS and we have the MapReduce. On top of that, we have a set of elements that basically talk to the data, to the HDFS via MapReduce. For example, here we have in that slide peak, we will see briefly in a minute, and we have Hive as well, which we will discuss in a little bit more of details, but basically allows me to somehow write SQL queries or something like that against the Hadoop cluster. Okay, we have a lot of additional components. For example, Michael was talking about the column family kind of databases. We have one column family kind of database, which is HBase. We have Pegasus as a graph database. We have Mahout as a machine learning package on top of the HDInsight. Now, the thing I want you to understand here is that Hadoop is not a product. Okay, so I'm not querying against a Hadoop. I might query against Hive that sits on top of a Hadoop cluster. Now, this is important. Why this is important? Well, you will see that later. But the thing is that once I set up a Hadoop cluster, this is not just a platform to do SQL querying or stream analytics with Storm, or it's an infrastructure that I can use to do any kind of distributed computing, whatever it is. Okay, so Hadoop clusters are platforms for distributed computing. They are not databases, okay? Well, there are other components I won't discuss right now. First things I think it's important is to know how can I create the cluster. So right now we are going to talk about Azure, about Microsoft's cloud. And we have several ways of creating the cluster. The most trivial way, of course, is just going to the management portal in Azure. By the way, bad news for you. Have you ever played with, well, how many of you have actually used Azure environment? That's good. Excellent. So for you, you will have realized that, ouch, what happened here? It will be fine if you tell me that the screen is not showing. Thank you. Okay, much better. So what you will realize is that this is the old portal. This is not Ibiza. So I'm afraid that we still don't have the new portal integration. So we are not going to see the shiny and flashy new experience, but we have the functionality for missing off. They are working on that, by the way, and it should be quite soonish. So here I have a lot of services, but you will see I have 2 HDInsight clusters already created. I just made this to be on the safe side in case something goes wrong, which I expect it's not the case. So let me, I don't know why it's not showing now. Let me go here, click on new, I can just create an HDInsight cluster. It's going to be for example, and you will see I can pass a set of parameters. I can set a cluster type. All of them are Hadoop clusters, but there are some pre-configured, predefined special set of clusters. Right now we have a special set of clusters for HBase, and this is because the topology for HBase requires having more nodes, zookeeper nodes, some special nodes on the infrastructure, and also I have a special template for Storm clusters as well. By the way, Storm is an amazing platform. I won't have time to cover it today, unless you want to ask me a question about that. I would be more than pleased to discuss that, but it's a brilliant platform for stream processing. Okay. I'm going to stick with the normal Hadoop cluster. Now, one very nice thing is that I can choose which operating system this cluster is going to be running. So I'm talking about an Azure product, an Azure, an Azure product, and I'm going to create this HDInsight cluster, this Hadoop cluster, either on Windows Server 2012 or on Ubuntu Linux. So I think that's really great. And in fact, I have one of each created to show you a couple of things about that. And I can choose also the version. By the way, when you're talking about the version, please just think on the Hadoop version, because the version numbering on, at least in the initial stages, the version numbering on the HDInsight is a little bit confusing. You have a version for the product as it is for HDInsight. You have a version for the Hortonworks release, because HDInsight is based on the Hortonworks data platform, and also you have the version of the Hadoop cluster that version of the HTTP is running. So it's a little bit confusing. Just stick to the Hadoop version, so you will see exactly what do you have there. Okay, so I'm just going to go ahead. I can choose the number of nodes I want to use. Of course, the more nodes you're using, the more you pay for that, because actually what this is creating is a set of virtual machines. By the way, if you create 4 data nodes, you are not just creating 4 virtual machines. You're creating 4 virtual machines for the data nodes, but you are creating also 2 head nodes, because that's there to provide high availability. I'm not going to discuss the head node and data node right now, but just bear with me with this. This is just to provide more availability, and also the zookeeper nodes. So you might create a 4-node cluster, a 4 data node cluster, but then you have 8, 9, 10 actual virtual machines running for you. So you select the region where you want to create that, or the VLAN, the virtual network, and you select the size of those machines. Obviously, the bigger the machines, the faster you can process the workload, if your workload is correctly defined, by the way. But the more expensive it will be. Now you create basically you create a username to be able to connect to it, and also you can enable RDP. And you can, this is very important. I'm not going to proceed longer with this, but this checkbox, if you've seen, when I click on it, a new page opens here. That will, well, I will show you just in a minute. Okay, you will see that it's asking for 2 SQL databases on the creation of the HDInsight cluster. Now, we will see this in a little bit of detail later, not so much, but the important thing here is that when I create a cluster, the data of the cluster I'm not storing in local disks of the virtual machines, because if I just delete the virtual machines, I will lose the data. What I'm doing with the data is store that in a Azure storage account, which is persistent. It's not transient, it's persistent. Now, the same thing needs to happen with the metadata. HDInsight clusters, Hadoop clusters, need a set of metadata for many things. One of the most obvious is the Hive tables. When I want to work like a SQL server, in a SQL server fashion, so when I want to work in a relational way with tables and so on, basically what it does is it has a table or a set of tables that says, hey, this directory on HDFS has data that maps to this table that you are creating with these sets of columns. Okay, so this is the metadata. If I lose that, even if I have the storage account and the data is already there, I will lose the ability from the cluster to query via SQL query to the data, because I don't have the metadata, I don't have the table definition. I'm not going to get into details, but this is very important, because if I don't do this step, I won't be able to spin up the cluster, shut down the cluster, spin up the cluster, and that's the main benefit of HDInsight, and we will discuss that later. So if I want to do that, I need to make this, to be very sure I make this to be stored in a SQL database. I'm not going to go ahead and well, continue with the creation of the cluster. It will be just a straightforward filling the rest of the fields. Instead, I'm going to discuss the rest of the options. The next option is PowerShell. So I have an SDK, I have an API that allows me to create and to alter an HDInsight cluster. And that API can be called with a set of PowerShell commandlets. So I'm not going to do the creation of it. I want to be a little bit cautious with the time. But I'm going to show it in a minute. By the way, I just realized that the comments are in Spanish. Sorry about that. But I'm sure you will be able to follow them. So basically, by the way, this is very close to something that we are doing in an actual project. We have the system set up in a way that we created with PowerShell scripts. So this allows me to schedule these tasks and, for example, programmatically create the clusters and to parameterize them to create the development, testing, and production clusters every morning at 8 a.m. and then shut down the clusters every evening at 9 p.m., for example. I can do that. I can not just say, hey, create a cluster with so many nodes, with this place to store the metastore and so on, but I can also pass all the personalized configuration on the test engine, on the MapReduce framework, to the Hive configuration, etc. So I can really customize my cluster to a lot of extent, to a great extent. So let's get back to the presentation. There's a third one. I'm not going to get into details with that, but you know we have in Azure this cross-platform CLI, so I can start working on my Ubuntu machine, on my Linux machine, or on my Mac. And I can just use the CLI and create my HDInsight cluster just as I do with any other component on Azure. So really cross-platform as usual. But then my favorite one is the HDInsight.NET SDK. I can programmatically create from a C# application or for a VB application, God forbid that. I can go ahead and create my own cluster. So I'm going to show this very quickly, but I'm not interested in you getting the details on how it is created, but I'm interested in to discuss with you why this is really so important. I'm going to discuss a very nice project we have related to that. Here I have a JSON file that describes my cluster. In this case, well, the cluster name is a placeholder I'm going to change later. User and password, please don't take this password and use it on my production environments. I promise it's not the production password. Then the cluster size in nodes, versions, operating system, specific configurations. So all I had in the other environments, you have it here. Now, programmatically, I have this cluster helper that allows me to get that configuration, that JSON file, and to pass it to Azure and state, hey, I want you to create a cluster that conforms to this configuration. Now, the good thing about this, the amazing thing about this is the following. Well, as I told you just a minute ago, on my HDInsight cluster, I have a couple of dependencies. One of it is the Azure storage. The other one is the metastore, the SQL database metastore. Okay. This allows me to do very interesting scenarios, like having, for example, multiple Azure storage accounts. You know, well, any storage account has a limit of, I think it's 50,000 IOPS. So if I'm going to have a lot of pressure on my system, if I'm going to have, and by the way, some of our projects, we do hit the limits by quite far. What we do is to create a set of different storage accounts, and all these different storage accounts configure them pointing to the same cluster. So that's some nice thing we can customize, but that's not the main one. The main one is this one, having multiple Hadoop clusters, multiple HDInsight clusters, pointing at the same metastore and the same storage account. In the end, what do I have with this? What I manage with this is the following. I can create multiple storage accounts that share this, somehow the state or the data, and that allows me to do the following. Imagine a system where I need to guarantee the performance of the execution of a job. If I'm only using one cluster, one HDInsight cluster, yeah, it's true, I can just add some nodes to the cluster, remove some nodes to the cluster, find the optimal point, the balance, and try to improve my performance in the case that I get additional users on the system. Well, that's fine, but I don't get the guarantee of performance on this job that there is no one that's going to somehow impact my environment. So what we are doing in one very sensitive project, it's a very big project, it's actually 300 terabytes of data. It's the version 2 of this project I told you about, the cookie level data integration and exposure path. By the way, we are going to be publishing a case study very soon about this. And one very interesting thing is that the customer didn't want to be impacted by other users executing other workloads. So what we did is, each time a user queues a job in the system, we have a website, they say, I want to do this with this data set, and I want to do it at this time in the day. So each time this schedule executes, what I do is programmatically, from our worker role running in Azure, it hits the schedule, it discovers, hey, well, I need to execute this job. So it creates a new cluster, and when the job finishes, it shuts down the cluster. So you might think, well, the cost is going to be higher. Not really. No, it doesn't have to be, because, and we have tested this well, in practical terms. The thing is, if I have the same workload running in a bigger cluster, then I'm obviously either I have performance problems, or I have a bigger cluster that, by the way, when I don't have this load, I'm well, wasting resources. So this works extremely well. Just controlling costs will be a good benefit, but the next benefit, which is equally, if not more important, is the fact that I can even customize these jobs for each specific user or for each specific workload. For example, imagine that one of the workloads comes from a very high person in the company and needs to be executed as ASAP. Well, I can go and change the configuration, the JSON template for this specific user, and say, hey, this is a very, very, very important customer, so let's give him, every time he executes this job, 128 nodes. So it creates a 128 node. By the way, we had to do that once. And the rest of the users, right now we're using 32 nodes on the clusters. So that's the kind of flexibility that this allows. By the way, try to compare this with an on-premise scenario. In an on-premise scenario, I don't have this option. In fact, if I need to add additional servers, I need to provision, I need to talk to the provider. That's going to take time. Okay, but well, let's move forward. Now we have the cluster. Now, how do I program with the cluster? How do I develop for the cluster? Well, I have many options, but let me ask this for you. Somebody, please talk to me, so I know you are still alive. How do you think we have to program against the cluster? How do we program against an Hadoop cluster? Anyone? Please. Sorry?
Hive and Pig.
Hive and Pig, that's very good. And also, normally the first thing that we always think about about Hadoop clusters is MapReduce. Sorry?
You write functions for map and reduce.
Yeah, programming against the MapReduce framework. That's correct. So the first thing is, how do we program against the MapReduce environment? Well, first of all, before I start even talking about MapReduce, by the way, many thanks. Before I even start talking about MapReduce, let me have this very clear. MapReduce is not what you are going to be using in your day-to-day operation. In fact, I would be almost willing to bet my hair that no one of you will ever have to write a MapReduce in production. Okay. The thing is as follows. MapReduce was a very good solution to start writing distributed logic against a Hadoop cluster. Let's discuss that briefly, and later I will tell you why it is not such a good tool for day-to-day operations. First of all, I hate this example I am going to show you. Okay, I hate it. There was a lot of occasions I explicitly refused myself to do the eternal word count example, but with many months, some years, I discovered that it's probably the best example for a couple of reasons. So bear with me with this. I really hate to do this. I really hate to use this example, but it's how it works. Well, basically, MapReduce divides all the workload in two functions, as you said, map function and reduce function. The map function basically gets, basically it's a list. The input is a list of keys and values, of pairs key and value, and it returns a list of key and value, another key that you might have transformed and another value that you might have transformed. Then, after the MapReduce finishes, all the elements get shuffled. We will discuss about that very briefly, and get processed in the reduce stage, the second stage. The second stage, reduce, basically gets one key and performs a computation for all the values in that key, and does that for all the different keys. Now, the canonical example is the word count. Okay, basically counting words. If I have here, for example, this sentence, and by the way, the fact that this sentence is part of the title and the lyrics of an Iron Maiden song, it doesn't have anything to do with the fact that I have long hair. Okay, this sentence, we can do the following. We can apply a map function that returns for each of the words a value of 1. So it starts getting all the words, and you see all the words in the sentence here. They has a day, and I append a value of 1, loneliness, and I append the value of 1, off, and I append day. I have another day, so I append another value of 1. After I do the map, I just make a shuffle to guarantee that all the tuples that has the same key, which is the word, by the way, in this case, the, are going to the same node. And then what I do in the reduce phase is just performing an aggregation, in this case, a sum of the values. Well, what I managed to do with this, I managed to count the words. Not very impressive, definitely, and I would say even quite boring. But the thing is that this is not done because this is fast. In fact, this is not a particularly fast way of counting words. But this is done because this is scalable. And that's the key. This is not fast, it's scalable. It means that if I just add a bunch of nodes, under certain conditions, I just can scale linearly. And that's what initially these guys were after. Okay? So the MapReduce works a little bit like this. We have a set of nodes that are going to start the map phase. They are going to fetch the data from the HDFS, this distributed file system we talked about earlier. And then for each of these chunks of data, with a set of transformations, it's going to apply this map function. After all the map functions have finished, and by the way, I can have a different set of nodes here and here. After all the map functions have finished, the data will get shuffled and distributed to another nodes to do the reduce operation. And then in the reduce operation, we have the reduce code, and then we write the results to the HDFS. And if you remember, at the beginning I told you that MapReduce was a Java framework. So how does this fit on the Microsoft store in this way? If I'm a .NET developer, how can I write a MapReduce without writing Java code? Well, first of all, don't do it. No, the thing is, for this windmill project I told you about, this Acciona project I told you about, we did both things I told you about. I'm going to tell you about. We did, first of all, using the streaming interface, and then we used the .NET SDK API. And I'm going to discuss you the pros and cons of each of those. First of all, the streaming interface. Imagine you don't know Java, you don't know any .NET language, and you want to write a MapReduce because you need to do some big processing on a cluster, and you need to make sure it completes on time. So what you can do, let's say that your only language is Python, for example, or whatever it is, if we can call Python a language. Okay, the thing is, if I write, for example, this Python executable, or even a batch file, if I write something that can get the standard input in, do a process, and write in the standard output, I can pass that executable as a map, and I can pass that or another executable as a reduce. And I can use any executable at all, and this streaming interface, this streaming jar, is going to take care of everything for me. So that sounds brilliant. That sounds like I don't have to learn Java. That sounds that I don't have to learn anything at all about MapReduce. That's simply not true. The fact is that I can use that, but it limits me a lot. I don't have any kind of I can only work with anything I can pass in a textual way, because I'm going to use the standard input and standard output. If maybe I have to do some kind of encoding. And also, and then for me, the biggest challenge is that I won't have any kind of debugging infrastructure on top of it. I don't have what's called the context. So I'm not going to get into details. Just be with me with that. It's not the best idea, okay? The second option, using the .NET SDK for Hadoop, that's much, much better if I don't want to write in Java. It's basically, in the end, it's basically using the streaming API. It's using the same thing, okay? But it abstracts you in a very, very, very nice way. Let me open. Well, I can just create a job. And you will see I have this executor context. I can create a job, which is a generic class of the class that I will create as a mapper and the class I will create as a reducer. They have to implement the interfaces for mapper and reducer. And I can just set up the initial settings and configuration in this job class, and then implement my mapper and my reducer. Okay, this is much better. In fact, there is some very nice thing that I can access the context directly. So I can, for example, log into the context. This helps with the debugging. I can use the increment counter, so I can set some performance counters, so I can track the progress of my operations. So it's definitely much better than using normal API. Now, if you need to do something very complex and you need to do a default, to not use the default splitter, if you need to do some kind of very specific process, and here I'm talking about, for example, fast Fourier transforms to do voice analysis, that's very challenging and very nice. Or if you have to do this kind of specifically binary operations, you are using binary operations and you have to split using these binary rules, and using a custom splitter, then do yourself a favor and just embrace Java and do the MapReduce. If you have to do it with Java, it's not so bad. Okay, so by the way, that's one of the very nice things that we are living in such an interoperable world. Okay, so let's move forward. Just give me a minute. Now. Okay, now I cannot ask my end users to write MapReduce jobs unless I'm for something very, very specific, like this kind of, for example, binary operations for doing image analysis, audio analysis, this kind of stuff. I cannot ask I don't know your users, but I can tell you my users, I cannot ask them to write MapReduce jobs. In fact, it's not so easy. Try to write a simple relational algebra left join operator in MapReduce, and you're going to have a couple of hours of fun. So there's a couple of side projects, like Big it's a scripting language, is something like that. I'm not going to get into the language, into the details, but obviously it's very, very much simpler than writing a MapReduce. Is very convenient to write. In fact, this is a very small sample, hides a very nice detail that I didn't talk about, and we don't have the time to discuss today, but one of the main things of the HDInsight, of the Hadoop platform and many of these big data products is the fact that you apply the schema when you are actually reading the data and not writing, what's called the schema read versus schema write. And that very simple thing, that's a major game changer. That's the reason why I go for NoSQL and big data projects for smallish projects like this wind power energy company. Like in this example, you will see this load entrada might be a directory full of files, and I'm saying that I just want to have these 3 columns. Then for this data set, I'm going to filter where x is greater than 5, and up to this point, nothing has happened. The only thing that has happened is that an expression tree has been built, and it's ready for execution, but it's just an expression tree. Now, when I write this dump p, what I have here is that this expression tree is going to be evaluated, and it's going to be converted into what? Anyone knows what it's going to be converted into? Once again, please. It's going to be converted into Java code that's going to execute MapReduce. So in the end, big, it's a wrapper for creating MapReduce. And that's good and that's bad. It's good because I don't have to write the MapReduce myself. It's bad because it's the same thing. Next, we have Hive. Hive is very nice. Hive is a great project. We use it a lot. We are really massive supporters of Hive, but Hive has a problem that makes you believe an HDInsight cluster or a Hadoop cluster is not what it is. Okay, so basically, Hive is the following. Hive allows me to do things like, whoa, whoa, I wasn't expecting this. Normally, I have problems with the Windows console that it's just too small. This time, I don't think that was the case. It will be quick. Okay, now whatever. I just logged into one of the HDInsight clusters I created before. This is a Windows HDInsight cluster. A little bit later, I will show you a Linux one. And you will see I open the Hive console, and now I can do things like show databases. I think I only have one. Show tables. I have this Hive sample table. Select, start. So let's start from Hive sample table limit 10. Oh. I challenge you to write on the Surface keyboard. By the way, I had a problem with my main laptop, so that's why I have to do this with this. Well, this is basically, you've seen a select. I can do, well, it covers most of the standard SQL 2011 standards. So in some ways, it's even more up-to-date than even SQL Server. I think that's going to change with SQL Server 2016. That's another thing. The fact is that, yes, I can write queries, I can do joins, I can do great things, but there's a couple of caveats to that we will discuss a little bit later. The thing is, this executes or used to execute MapReduce jobs as well. Okay. Now that's not so good because MapReduce is not fast. In fact, it's actually quite slow. It's scalable. That's great, but it's slow. Okay, so that's why Hive shouldn't be considered a substitute for a data warehouse, normal data warehouse, or, well, a data warehouse, well, it could be, or you could consider that a data warehouse, but definitely an OLTP, you will forget about that. In fact, up to the version 2.0, you couldn't even create new insert data, update data, delete data. It's just append only, okay? Well, then we had a set of nice tools on top of that. For example, we have Cascading and Scalding, which is cascading on top of Scala. And you will see that this looks a lot like entity framework, like query expressions. And it's actually, when I'm writing code, for me, this is much, much, much better than working with MapReduce most occasions. So this is the kind of way we like to work. But in the end, the problem is that everything was MapReduce. And MapReduce had a lot of issues. So I'm going to be very quick because I have very little time left. So I'm trying to wrap this in 2-3 minutes. But keep in mind with this. Up to Hadoop 2.0, up to not so long ago, everything was MapReduce. Even the same cluster was built just to execute MapReduce. That changed with Hadoop 2.0, in which we add this new layer here, which is called Yarn, yet another resource negotiator, which is basically, you can consider it as the operating system in top of the Hadoop cluster or the HDInsight cluster that allows to orchestrate resources and basically substitutes the job scheduling component of the task scheduling component of the MapReduce, and allows you to add new paradigms, new ways of programming. For example, now we have Hive working with two different modes, MapReduce, the batch mode, the old mode, and also test, which is a new engine of execution that allows you for real-time queries. There was this Stinger initiative that managed to get real-time queries on top of Hadoop clusters and HDInsight. By the way, well, I don't have time to discuss that, but a very, very interesting project. But also, you can have other completely different kinds of workloads running that don't have anything to do with MapReduce. For example, we can have this Storm running directly on Yarn and doesn't have to be impacted by the architecture of the MapReduce. So this allows you to start working with real-time queries. We are getting queries in the low seconds, and this is improving. And I'm sure this year we will get queries in the less than a second range. And we are getting things like, you will see things like memcached running on HDInsight clusters or Hadoop clusters, distributed in a farm of servers. There's this wonderful project which is called Killing, which is an OLAP engine running in top of Hadoop that you can run on top of HDInsight now. And you can run in top of HDInsight now because this little nice thing that I'm going to show you now, and I'm going to finish with it, which is the fact that you can now create these Linux clusters. These Linux clusters, you can simply execute, go to any Apache project, for example, Fort Knox or whatever the project you want to create, and you don't have to wait until the HTTP platform is released on Windows and has this product. You can just go compile and put it on your oh. Okay, I can solve this. I know what happens. That's the old credential, sorry about that. So you can just connect to your cluster of Linux machines, use Amvari, connect via SSH with PuTTY or the application you want to use. So you can just install whatever you want here. So you notice there's a new project like Killing, for example, that we are going to be using on this very, very big project, and we are starting evaluating Killing. So we just see Killing is there. We just get the binaries. We just get the source, compile, deploy on the cluster, and you're ready to go. So last two slides. Just to summarize, we have a very nice story with HDInsight, which is the Hadoop cluster, but there's more to it. We have machine learning. We have the orchestrator features in the Azure Data Factory that you can also use to spin up clusters and delete them to create them on demand. And you can even have, well, they are recently announced, but you can even have this appliance, this APS on Azure, which is the Azure Data Warehouse, which is basically a mix between the SQL databases and APS that can connect directly to HDInsight databases or Hive databases or even the HDFS. So we have a lot of things to play right now. The only thing I want you to keep in mind, and this is my last sentence, but the only thing, my main goal for this talk is that from today on, when you talk about Hadoop clusters or HDInsight, you don't think only on MapReduce or a database, because it's not just Hive, it's not just the analysis on peak. You can have a lot of different products running there. Memcached is It's not a database. You can have killing. You can have a lot of things. So it's a distributed it's a distributed computing platform, not just a database. That's one of the main takeaways. The other one is that obviously big data is not just Hadoop. It's just one of the parts of one of the products that we can say enables big data. Okay, that's it for me. That's it for me, basically. So I don't know if you have questions. I don't even know if we have time for questions. Maybe one question. Anyone has? Okay. So I think we can skip that minute. If you want to discuss anything, I'll be around a little bit later. Okay. Thank you for your time. Cheers. Thank you.